I'm going to preface this video by stating that I have a sinus infection, and so I'm going to sound even worse than I normally sound. But it's a shorter video, so that's good for you. And I also want to congratulate the football team for the great win on Friday night. And way to go band and cheerleaders and dance team and everybody else. By the end of our video today, you should be able to divide polynomials. Okay, our first example here is just a polynomial by a single monomial. And you won't have many like this, but I wanted to show it to you just in case, because we're going to need to use the same concept when doing the long division of the other ones we get to in just a few moments. And so what we do is you take each term in the trinomial in the numerator and divide it by the monomial in the denominator. So each term is going to be divided by the 2x. Excuse me. And then our last term, negative 4x over 2x. So 4x to the third divided by 2x becomes 2x squared using our division properties that we learned about exponents last unit. And then we have 8x squared divided by 2x, which is 4x, and then negative 4x divided by 2, which is negative 2. And so this trinomial would be the answer to this division. The process for dividing two polynomials is a bit more involved, but it's similar to the process of long division when we divide integers. So in this particular problem, I want to point out that the number on the outside here is called the divisor. The number on the inside is called the dividend. Oops. And then our answer that we're going to get on top is called the quotient. And so recalling long division from way back in elementary school, I have to see how many times the divisor will go into the dividend. And I know that 15 will go into 84 5 times. So then we do 5 times 15 and get 75, which we take away from the 842. Well, actually from 84, excuse me. And that gives us 9. Then bring down the 2, and we're going to see how many times 15 will go into 92. And I know that that's 6. So I do 6 times 15 and get 90. And I have a remainder of 2. And so remember, that's called the remainder, which we're going to have today too, so we won't continue it. Now, I'm not trying to insult your intelligence by doing this problem. I just want to give you a refresher because we're going to apply this process to polynomials. You can always check your answer to these problems by taking the quotient multiplied by the divisor, adding the remainder, and that should equal the dividend. Remember, the dividend is what is underneath the division symbol. So the quotient in our case was 56. Our divisor was 15, and we had a remainder of 2. And so we want to see, is that equal to our dividend, which was 842. And when I do that math, I find out that yes, it is 842. And so that means we did that correctly. This same process can be applied to division of polynomials and checking your answer there. Okay, so we're going to divide these two polynomials. This one right here will go within the division symbol. And so that's 3x cubed plus 4x squared plus x plus 7. And the other one will go on the outside. Now I do want y'all to make a note that you see how each of these polynomials is in descending order from greatest exponent to least? That's how you want them when you're doing division. So if they're not in order, we're going to have to order them, but these are. Okay, so your first step will be to divide the leading term of the dividend, that's the 3x to the third, by the leading term of the divisor, which is x squared. So we're going to do step 1, 3x cubed divided by x squared. And that gives me 3x. And I'm going to write that term at the top here just like I would in normal integer division. The second step is to take that 3x that we just got and multiply it by the divisor. So step 2, we're going to do 3x times x squared plus 1. When we perform that multiplication, that gives us 3x to the third plus 3x. So all we did was take our answer from step 2 and write it here. Now notice that when I wrote it, I went ahead and wrote the 3x way over here instead of right behind it because I'm lining up my like terms to make my next step more simple. So following this, just like in integer division, we're going to subtract. So these first two terms of 3x cubed are no longer there. Then we have 4x squared. And remember we're subtracting, so we have x minus a positive 3x, which could give us negative 2x. And then we have our plus 7. Alright, now we're going to repeat the same process. I want to take the leading coefficient here and divide it by the leading coefficient on my divisor. So I'm going to do 4x squared divided by x squared, which happens to be, which gives me 4. So I'm going to put plus 4 on the top as part of my quotient. And then just like I did step 2 over here, step 2 for this second round is 4 times the divisor. When I do 4 times the quantity x squared, I get 4x squared and a positive 4. And notice this time I wrote my positive 4 over here under the 7, because they're like terms. And again, we're going to subtract. So the 4x squared minus the 4x squared is gone. Then we have negative 2x minus nothing, so that's just negative 2x. And then we have 7 minus 4, which makes positive 3. So now again, if possible, I repeat the process. So I take negative 2x, and I want to see if x squared will divide into that. And I know that it will not. So this down here, all of this stuff will be my remainder. So our final answer would be, we would say the quotient is 3x plus 4 with a remainder of negative 2x plus 3. And if you wanted to, you could check your work again with this formula, and I'm not going to take the time to do that tonight. Okay, so here's one more example for us. And first of all, we need to make sure that this is in order from greatest exponent to least exponent. Greatest exponent to least exponent, it is. And the one thing we want to notice is this goes 4, 3, and it skips x squared. So when we set our problem up, we're going to need to leave a space for that term. So here we go. I've got x to the 4th minus 3x cubed. Then we'll leave a little space for the squared term, plus 2x minus 5. And on the outside, we have our trinomial this time, x squared minus x plus 1. So just as we were doing earlier, we're going to take the leading term here and divide it by the leading term on our divisor. So that would be, step 1 would be x to the 4th divided by x squared, and I know that that's equal to x squared, so that goes here. And step 2 would be to multiply x squared times this trinomial. When I perform that multiplication, I get, get my pen back, x to the 4th minus x cubed, oh, I can't write either, plus x squared. And so that's where our space comes in up here. We have an x squared term now. And just like before, we're going to subtract. So our x to the fourth and x to the fourth subtracted go away. Negative 3x to the third minus a negative x to the third gives us negative 2x to the third. And then nothing minus x squared gives us negative x squared. And then we're just going to bring down our last two terms. And just a note before we go on, I think where most people make their mistakes on these problems is the subtraction part, because you have a tendency to want to just combine like terms and you're really subtracting. So please be careful on that. So again, repeating the process, I'm going to take negative 2x cubed and divide it by x squared. So negative 2x cubed divided by x squared, and that provides a negative 2x, so that goes up here. And then we're going to multiply negative 2x times the trinomial that is our divisor. So when I perform the multiplication, I get negative 2x to the third and positive 2x squared and minus 2x. And now I do my subtraction. Negative 2x cubed minus 2x, negative 2x cubed is gone. And then we have, this is supposed to be plus, it looks almost like a 12, plus 2x squared. So negative x minus 2x squared gives us negative 3x squared. And then we have 2 minus a negative 2x, which is positive 4x. And then we bring our negative 5 down. Alright, repeating the process again. We take the leading term, divide it by the leading term here. So that gives us negative 3x squared divided by x squared, which just gives us negative 3. And now, performing negative 3 times this trinomial, whoops, didn't mean to move my screen, times this trinomial, and we get negative 3x to the second, positive 3x, and negative 3. Now we're going to subtract. So these negative 3x squared minus negative 3x squared is gone. 4 minus 3x is just x, and negative 5 minus negative 3 is negative 2. So our final answer, we would say we have a quotient of x squared minus 2x minus 3 with a remainder of x minus 2, because x squared will not divide into x. So we are done with this problem. And again, as a reminder, you could check your work if you would like. These problems take a little time to do, but they shouldn't be too difficult to do. And here's just a little cartoon to end the night on, and I'll see you all tomorrow.